now when we look at simultaneous equations, basically what we have is we've got two equations of two different lines, and we're finding the point where the two lines intersect. So there's three possible things that could happen. We could have two lines which are graphed, and you can see that they can intersect at one point. If they intersect at one point, we say that there is one solution. There's also the scenario where we'll have no solution. So if you consider two parallel lines will never touch each other. So sometimes if we were to graph two parallel lines, and what do we know about the slope of two parallel lines? They're the same. So when we have those parallel lines, they will never intersect each other, and therefore there'll be no solutions to that equation. And then the final scenario that we could have is there could be an infinite number of solutions. Which means that if we graph two lines, that they actually coincide with each other. So every single point on each line is coincidental, and there's an infinite number of solutions in that case. So, like I said, there's a number of ways we can actually solve these. The first way we're going to do it is graphically. So what graphically means is let's graph each of the two equations of the lines. Once we've graphed the equations of the line, then we can find where they intersect, if they do intersect, and then that's going to suggest what the solutions are. All right, does that make sense? All right, now, we've learnt the skills to graph these, so we should be good to go. Let's start off with, we'll graph the first one first. So y equals minus x plus 4. This is in gradient intercept form. So the plus 4 tells me what? The y-intercept. So I've got a point at plus 4. Then the minus in front of the x is telling me that the slope is minus 1. So minus 1 over 1. So that means I could go 1 unit down and then 1 unit across. So if I come 1 down and 1 across, there you go. I've got 2 points. As soon as I have 2 points, I can join them. All right, so I've joined them together. Now, that was this one. So next, I'm going to graph this one here. Once I've graphed that one there, I'm going to find the point at which they intersect, and that's going to be my solution if they do intersect. So what's my y-intercept? Minus 2. I might do this one in a different color. I'll do it just so you can see the difference. So we've got minus 2. And then the slope is 5 over 1. So I come up 5 positions and move across 1 position. 1, 2, 3, 4, 5, and 1 across happens to be there. And then I can join my 2 points. And I'm just going to label the equation of the line on each of them. So this one here is y is equal to minus x plus 4. And then this one here is y is equal to 5x minus 2. And look at this. They meet at this point here. So what point is that? What are the coordinates of that point? 1, 3. So therefore, the solution is x is equal to 1, y is equal to 3. All right, so that's how we do a graphical solution. I'm not going to do the other ones because they're going to be practice for you. With C, is this in gradient intercept form? No. So when we have a graph that's not in gradient intercept form, we can't just say that the number in front of the x is going to be the slope. and that the constant value is the y-intercept. What we have to do is we either have to write it in gradient intercept form, or this is called general form. There's another trick that we could do to help graph these. We can use the intercepts to help us graph it. So in fact, we might do C together. So let's consider the first equation. So 2x minus y is equal to 5. Now, for this graph here, let's think about the x-intercept. So the point where it's going to intersect the x-axis. What will be the value of y when our graph intersects that x-axis? 0. So x-int when y is equal to 0. Agreed? We'll find our x-intercept when our y value is equal to 0. Then let's substitute that in. So if our y value is 0, then 2x is going to equal to 5, and x will therefore be equal to 2.5 or 5 over 2. So you might say, well, what was the point of that? Now I know that when x is 2.5, that y is 0. So I can plot a point. Okay, so I've plotted a point. How many points do I need to graph this? 2. So let's find another point for that first equation. So the y-intercept occurs when? What will be the x value when it intercepts the y-axis? When x is equal to 0. So if we substitute x is equal to 0 into this equation, then 0 minus y will equal 5. So therefore, minus y is equal to 5. So y is equal to minus 5. So when x is 0, y is minus 5. Do I now have 2 points? Yes, so can I graph that line? All right, let's connect them together. So that was the equation of 2x minus y is equal to 5. Now, we have to graph the other one still. So let's consider our other one. If I have, let me just give myself a little bit of room down here. So let's consider this one here. X minus 2y is equal to 4. So let's first find the x-intercept. X-int when y is equal to 0. So when y is equal to 0, what's x going to be equal to? When y is 0, so if I substitute 0 into that, what's x going to be equal to? 4. Can you see that? X minus 2 times 0 is just going to be 0, so it's just going to be x is equal to 4. So our x-intercept for this one is going to be at this point here. X is equal to 4, y is equal to 0. Then our y-intercept is going to occur when x is equal to 0. Yeah, x will be 0 wherever it intersects that intercept. So if we substitute x is equal to 0 into here, then I'm going to have 0 minus 2y is equal to 4. So minus 2y is equal to 4. So y is equal to 4 divided by negative 2, which is negative 2. So when x is equal to 0, y is equal to negative 2. And then we can graph this. We can graph this. And this point where they intersect is our solution. So what's that point look like to you? 2, negative 1. So, therefore, solution is x is equal to 2, y is equal to minus 1.